Welcome to this NIS307 session. My name is Tom Adamski. I'm a principal solution architect focusing on networking. I'm joined today by Jamie, also a principal SA. And today we have a session for you on zero trust within application networking. And what we'll cover today is we'll talk a little bit about the definitions of what is zero trust and what is application networking. And then we'll move on to focusing a little bit more on identity and identity management. Specifically, we'll focus on two use cases, human to application communication, and then service to service. So starting off with zero trust, what is zero trust? And I won't read the definition. I'll let you have a look at the definition. The gist of it is that zero trust is not a single thing. It's a mechanism or set of mechanisms that allow you to go beyond the traditional networking constructs to provide security to your services. And if we look at the security controls available within zero trust, we can split them into two categories. We can have identity-centric services or network-centric security controls. Identity-centric, an example here could be an EC2 instance with a role that's communicating with an S3 bucket, and we're permitting that role to be able to upload and download objects into the bucket. Network-centric controls are based around IP addresses, ports, and it could be applied by things like security groups or network access control lists to decide what's allowed to and from your EC2 instance. And ideally, within the zero trust framework, you want to use both. It's not one or the other. It's a combination of both to achieve the optimal result. So you're using the identity-centric controls in combination with network-centric controls. I'm not going to spend more time on defining zero trust. If you want to dig deeper into the overview of zero trust, we actually had a really good session from reInvent last year, and we will have another session today at 12:30 on zero trust if you want to just focus purely on the zero trust constructs. Moving on to application networking. So application networking is a set of solutions that allow you to improve your application's networking architecture. And by improve, we mean improve security, availability, performance. And when we talk about application networking, we're looking at using that application layer to have intelligent navigation of traffic within your network. So if we compare application networking to traditional networking, let's explain traditional networking. We have a client and a server. Each one has an IP address. And there will be some kind of device in the middle that allows for these two to communicate, like a router. And all we're using in this scenario is the IP addresses to communicate. The router has no awareness of anything that's in the payload. It's just forwarding traffic from the client to the server. That's it. When we talk about application networking, we're starting looking deeper into the application layer. So we still have a client. We still have a server. But in the middle, we might have a device or solution that's a little bit more advanced, like a load balancer or a proxy, that's able to understand more about the traffic. So we can start using additional information, whether it's about the client, like the username or user agent, or the server side, like the host someone's trying to connect to, or the path, and then use that to make a routing decision or load balance the traffic to the backend or add authentication or authorization. IP addressing is still used in this scenario, but mostly to just deliver traffic from A to B. It's all about that application layer and those decisions within the application layer. Again, that's it on application networking. I'm not going to spend more time on defining what it is. There is another session from reInvent last year that you can go out and check. So we know with zero trust, we have these two types of security controls, identity-centric as well as network-centric. And these very nicely map to the application layer and the application networking construct. So identity-centric really nicely maps to application networking. And then network-centric maps to those traditional networking constructs, so using IP addresses and ports. And in today's session, we'll spend the whole session talking about identity within application networking services. So let's do a quick history recap on how identity works and how we can think about identity. Typically, we have for human to application communication, we have some client, some user trying to consume an application. That application might have an identity store. And as long as the client has the username and password, they can connect. Now, when this scales, it becomes more complicated. You don't want to have a client having to have different passwords for different applications. So there were technologies developed that allow you to centralize your identity layer and integrate that with your clients and your applications. So maybe it's Kerberos on-premise, or out on the internet, things like SAML or OpenID Connect. Now, you might also want to hide your applications from the outside world. So often what you might deploy in front of your applications is some kind of authentication proxy that can integrate with the identity provider and then authenticate and authorize the user before it allows traffic to your backends. And that's most of the architectures we're going to be talking about today. And there's often some questions we get from customers about these types of architectures. So things like, can I also validate the device posture of where the client's connecting from, rather than just validating the identity? What are the things that are being sent between the identity provider and the client, or identity provider and the proxy? And what is that proxy actually forwarding back to my application? And this is just a human-to-application use case. We will also talk about the service-to-service use case, and we'll map out different application networking services to those use cases. So for human-to-application, we're going to talk about application load balancer and authentication. We'll also talk about AWS verified access, authentication, and authorization. Amazon API Gateway is kind of in the middle between the use cases, a little bit more on the service-to-service use case. It mostly does authorization, although it has some authentication options as well. And then I'll hand off to Jamie to talk about Amazon VPC Lattice and how it deals with authentication of authorization for service-to-service communication. OK, so let's start with the first use case, human-to-application communication, application load balancer. So application load balancer is part of the Elastic Load Balancer family, and it's focusing on delivering HTTP and HTTPS application. So you can receive traffic from different sources, whether they're on the internet or internally within your environment, and then distribute that traffic to different kind of backends, EC2 instances, Lambda functions, containers, even IP addresses, whether on AWS or on-premise. An application load balancer focuses on HTTP, so it will handle a lot of the different HTTP protocols, and it has a set of functions like intelligent routing, sticky sessions, and so on, to deliver the traffic to the backends. And it integrates with different security services like AWS WAF, Certificate Manager for managing your certificates, and then Amazon Cognito for authentication. So throughout the session, we're going to use a lot of examples. So I'm going to show you an example of how an application load balancer is configured, and then we will add authentication to the existing load balancer. So in this scenario, we have a VPC with an application load balancer. We have WAF enabled on it to do inspection of traffic for things like SQL injection and cross-site scripting. We have a TLS listener with a certificate. And we have two different target groups. So one happens to be EC2 instances. The other one happens to be containers. And we can configure our load balancer to look at the host headers, and based on the host headers, decide how the traffic gets forwarded. So if we see app 1, we want to send traffic to target group A. If we see app B, we want to send traffic to target group B. Now, say we want to add authentication to our load balancer. We have two options. We have native integration with Amazon Cognito, which is AWS, a managed service for authentication that also allows you to integrate with social identities, so Facebook, Amazon, Google. And the other option is integrating with third-party OpenID Connect providers. And that's the option we're going to focus on today because it's a little bit more complex than integrating with Cognito. So if you want to add authentication with a third-party IDP, what do you need to do to make it work? OK, so first of all, you got to decide on your IDP. You can have open source options. You can use things like Okta or Ping1. And then each identity provider is going to have a number of different endpoints, which are effectively URLs. There's going to be an authorization endpoint. There's going to be a token endpoint. And there's going to be a user info endpoint. And I'll explain in a second how are these being used in the authentication process. Then we need to create a client configuration within an identity provider. And in this scenario, the client is not the user. The user will also be on an IDP, but defined as a user with their credentials. We need to configure the client in this scenario is the app or the application load balancer. So we'll have to create an ID for it, a secret, the URL that someone's going to use to connect to it, and then a redirect URL. So once a user is successfully authenticated, where should we redirect that user to. And then in the application load balancer and configuration, we need to specify all those details. So we would input and map all those details to the application. Looks like the arrows are hidden behind the diagram here, but you can imagine them going into different lines. So we have to define the authorization endpoint, the token endpoint, and user info endpoint in the configuration, as well as the client ID and client secret. Okay, so once we've defined everything, we said that we want to authenticate traffic that's going to our app 1 before we forward it to the target group. So a user connects to our load balancer with a simple GET. The user is not authenticated yet, so we will redirect the user to the authorization endpoint that we've defined earlier. So now the user will hit our identity provider on the authorization endpoint. The user will authenticate, and the IDP is going to generate an authorization code. It will return the code to the user and redirect the user to the redirect URL we've also defined earlier on the identity provider. Now the user will send the code to the application load balancer, and then the application load balancer will use that code to continue authentication. From this point onwards, the communication happens between the application load balancer and the IDP, and the user is not part of this exchange. So if you're on the user and you have Wireshark or you're monitoring the traffic, you're not going to see any of those exchanges. These are happening between the load balancer and the identity provider. So application load balancer uses the authorization token to do some exchanges now. It will send the token to the token endpoint, so it will send the authorization code to the token endpoint, and it will receive JSON Web Tokens in exchange. There will typically be 3 tokens: ID token, access token, and a refresh token, which is optional. The application load balancer receives the tokens, and if we want to zoom in on how these actually look like, I'm going to show you an example with the ID token. By default, it's base 64 encoded JSON Web Token, so you need to decode it to actually make any sense out of it. So when you decode it, you'll see there's 3 different parts to that token. There's a header, there's a payload, and there's a signature. In this scenario, the signature, the token would be signed by the identity provider, so you can validate its authenticity. In the payload, you might have some information about the user or information about the identity provider and so on. Okay, so load balancer has the 3 tokens. It will now use the access token to connect to the user info endpoint, effectively send the access token to the user info endpoint, and receive user information from the user info endpoint. So now we know who the user is. It's Alice Adams. She's part of engineering group, and she has an email, and that email is verified. At this stage, Alice has been authenticated successfully, and the application load balancer is going to set an application load balancer cookie and redirect Alice back to the original URL that she started with. So Alice connects again to app1.example.com, but this time she has the cookie generated by the ALB. So she's successfully authenticated, and the traffic can be forwarded to the backend. Now, the application load balancer in this scenario adds additional headers when it's forwarding the traffic. So we can zoom in and see what those headers are. There's 3 headers: X Amazon OIDC, access token, identity, and then data. The access token is the exact copy of the access token we received from the identity provider, still signed by the identity provider. The OIDC identity is just an ID field of the user, and the OIDC data is a copy of the user info we got from the user info endpoint. But this time, it's signed by the application load balancer. So you need to get the public key published by AWS to be able to validate the authenticity of the user info information here. Now, you can use that information on your application to do some additional authorization. So application load balancer, all it did was authenticate your user, but it can't do authorization. So it's up to you to configure your application to look at these headers and decide, OK, Alice is part of engineering group, so I'm allowing her to do something on my application. From a logging point of view, application load balancer allows you to generate logs of any communication that happens on the ALB. You can see the source destination IP addresses, the path that was accessed, and the fact that there was authentication occurring. Unfortunately, you will not be able to see the details of the user that's trying to authenticate. Okay. So moving on from ALB to another human-to-application use case, this time AWS Verified Access, or AVA, as we like to call it short. So AVA adds additional capabilities to what we've seen with Application Load Balancer. It allows you to have fine-grained dynamic authorization. So it's not only authentication, it's now authorization on the AVA layer before the traffic gets passed to the backend. It also improves observability. So from the logging point of view, you'll be able to see exactly who's being authenticated or not authenticated and why. And then finally, you can use your existing security services like your identity providers, or in this case, even device management providers. So if you're using Jamf or CrowdStrike, you can validate the posture of the device of your user before you allow that user to connect to your application. Okay, so let's use an example here for AVA as well. We have a VPC. This time we have a private application load balancer with only a single target group. And we've deployed AVA in the region. AVA also integrates with AWS WAF, so we can apply the same security controls we want on our web applications. And AVA does authentication and authorization. So user connects to AVA. We would set up a DNS so that application points to AVA instead of whatever our actual application was. We will apply a policy here to decide if the user is authenticated and if we can authorize the user to continue connecting to the backend. And if successful, traffic is going to be forwarded to the application load balancer. And AVA can point to a number of different things inside a VPC. It can point to an application load balancer. Again, it has to be internal. A network load balancer also has to be internal, or an elastic network interface that's assigned to an EC2 instance or a container. Now, from a construct point of view, when we're building AVA, we have to create a bunch of concepts like AVA instance, which encompasses all of the constructs we will be using, and it integrates with all of the trust providers. Within an AVA instance, we would be defining the endpoints, or effectively our applications. And in this case, it could be the application load balancer, network load balancer, or network interface. And then finally, we can group our endpoints into different AVA groups. And the reason why we would use groups is because we can apply a policy on a group level as well as on an endpoint level. So in this example here, I have a finance group, an IT group, and I'll have a high-level policy for any endpoint in that group that maybe I require that every single email is verified of anybody that's connecting. And then I could have more granular policies deeper inside for each individual application defined by the application teams deciding on what I want to allow to my application. So maybe I have to be part of the finance group to be able to connect. Now in this session, I'm not going to show you how to set up all of these constructs. We're going to still focus on identity. But if you want to have a look at setting up AVA from scratch, we actually have another session from reInvent last year that goes into that detail. Okay, so let's start integrating AVA with different trust providers. So the options we have here is we can integrate with an OpenID Connect identity provider, just like ALB could. We can integrate with a third-party device management provider. Today it's Jamf or CrowdStrike. Or we can integrate with an AWS managed solution, AWS IAM Identity Center, which used to be called AWS Single Sign-On. So if you have a SAML identity provider and you want to integrate with SAML, you would have to do it through IAM Identity Center. Now, if you want to have a look at a list of different AVA partners, whether they're identity providers, trust providers, or observability providers, you can check them out here. But let's start setting up the integration. So similar to the integration with Application Load Balancer, we will focus on the OpenID Connect use case because that's the one that's a little bit more complex. Just like before, our IDP has 3 endpoints: authorization endpoint, token endpoint, and user info endpoint. And we would deploy AVA in front of our Application Load Balancer to set everything up. Now, just like before, we need to create an integration. So we would create a trust provider. And notice I'm giving the trust provider here a specific name. I'm calling it IDP. And then I have to populate all the fields with all the information that I have about the authorization endpoint, token endpoint, client ID, and so on. OK, so once I do that, I'm ready to set up a policy. And for setting up policies on AVA, we've developed our own policy language called Cedar. We've actually open sourced it if you want to have a look at the source code. And it's using three areas. So there's going to be an effect, where in our case, it's mostly going to be permit. And then scope, which we don't have to use in the case of AVA. And then where we will spend most time is the condition clause. So this is where we will be deciding what conditions do we want to be met before we allow someone to connect to our backend application. And then we would configure those policies and deploy them, again, either on the group level or within the individual endpoints. So here is an example policy where I'm saying I want to allow anybody to connect to my application, but only if they're part of the engineering group and only if their email is verified. So I'll get that information back from my identity provider. I'll be able to parse through it and see if it matches. Now you can see here in orange, I'm marking the IDP. This is the reference name I've defined when I created this trust provider. So whatever you call it, you'll have to use that same name in your policy. Okay, so let's talk about the flow, and you'll see that the flow is exactly the same as with the application load balancer, with major differences at the very end when we can actually do authorization, not just authentication. Okay, so user connects to AVA. They get redirected to the authorization endpoint, just like before. They connect to identity provider. They get a prompt to authenticate. They authenticate. They receive the authorization code. That authorization code is sent back to them with a request to redirect back to AVA. They send the authorization code to AVA, and now AVA can use the authorization code to get additional information about the user. So it will connect to the token endpoint. It will receive the JSON Web Tokens. And just like before, it will use the access token to connect to the user info endpoint and pull the information about the user. So you have to provide a token to get the user information. So again, when you get the user information back, it's still Alice connecting. She's still part of engineering group. She has a verified email. So we can now cross-check the information we got from the user info endpoint against the policy we've defined, and everything is matching. So in this scenario, Alice is going to be allowed to connect to our backend application. So what we'll ever do next is create a cookie, send that cookie back to the user, back to Alice, and tell Alice to connect back to the application again, but this time provide that cookie with her. So the user connects, provides the cookie, and at this point, AVA can forward the traffic to the backend, and it also includes one additional header to the backend application. So let's have a look at what's in that header. The additional header is AVA user context, and all AVA is doing is effectively copying the information from the user info endpoint, but this time it's being signed by AVA, not signed by the identity provider. And you can decide to do something with it and use it for additional authorization, but AVA is already giving you a way to authorize your users, so you may not need that additional header at all. Okay, so let's talk about the second option, using device management solutions. So let's assume Alice is using an Apple device, so we will use Jamf. But if she didn't use Apple, we could use CrowdStrike. We need to create another trust provider, this time for Jamf, and specify the tenant ID for our Jamf deployment, which we would get from Jamf. We will then need to specify within the AVA instance configuration that we want to use both an OpenID identity provider for authentication, as well as the device management provider for validation of the device. We also need to update our policy. So now we're saying we want to allow someone to our application, but only if they're part of the engineering group. Their email is verified, but also Jamf is telling us that the risk level of their device is low. And again, you know that the names in this policy are coming from whatever you've named your trust provider. So I called it IDP, and then the second one is called Jamf. So how does the flow look like for that Jamf integration? So to be able to access the application, Alice now has to install an additional browser plugin, AWS Verified Access. That browser plugin is going to communicate with the local deployment of Jamf agent on her device. They'll be able to get encrypted information from that Jamf agent and pass it on to AWS Verified Access to be able to apply a policy. So as long as Alice now has a device that's that has a low risk and she's authenticated, she's going to be able to get access. Okay, from a logging point of view, we can see a lot more information than we could see before with ALB. We can see successful authentication events, but we could also see access denying events and different reasons for why the access was denied. And we can send our logs to different destinations, CloudWatch, S3 buckets, Amazon Kinesis Firehose. And I have an example here for you where we're sending traffic to CloudWatch, and we have an example log entry saying that someone was denied access because they didn't authenticate. Okay, so this were our human-to-application use cases. And we talked about ALB, and we talked about AVA. So let's talk about some of the differences and when to use which one. So ALB authentication is only doing authentication, whereas AVA supports both authentication and authorization. Application Load Balancer integrates with OpenID Connect identity providers and also Amazon Cognito if you need these social identities, again, Amazon, Facebook, Google. Whereas Verified Access also integrates with OIDC providers, but it also integrates with IAM Identity Center as well as device trust providers like Jamf and CrowdStrike. Both solutions support WAF. And then Application Load Balancer is ideal for scenarios where you may want to add authentication to your public-facing application, whereas AVA use case is more focusing on these private corporate applications that you want to give access to without having to set up a VPN. Okay, so let's move a little bit away from the human to application use cases, although Amazon API Gateway also supports that use case as long as the client on the end user can connect to the Amazon API Gateway. But the use case that's more common here is service-to-service communication. So with Amazon API Gateway allows developers to build their APIs at scale, deploy them, and centralize access to them through a single service. If we look at the API Gateway architecture, API Gateway itself lives in the region. It doesn't live inside a VPC. It supports things like caching and logging, and there's a number of ways that you can use to invoke an API. You can do it publicly through an edge-optimized endpoint or regional endpoint, but you can also expose your APIs privately through an endpoint that lives inside a VPC. So that's the front end, someone connecting and executing an API. Now on the back end, there's also a lot of integrations. So you can send your traffic to a Lambda function, you can send it to an EC2 instance, effectively any AWS service. You could send it to public endpoints, and you can also send traffic to private things inside your VPC. For the use case today, we're going to keep it very simple. So we're just going to focus on someone executing the API, maybe on the public path, and then we'll look at the different options for authentication and authorization. Now, we have two different types of APIs with API Gateway, REST and HTTP APIs, and each one has a number of security features. We could spend the whole day talking about all of them, so I had to pick a few that we're going to focus on today. We're going to talk about mutual TLS first, and then we'll talk about JSON Web Token Authorizer and custom authorization with Lambda. So let's start with mutual TLS. So mutual TLS allows us to deploy an X509 certificate on the client and use that to authenticate the client when it's connecting to our API. So that certificate would be signed by some certificate authority. So we need to provide that certificate authority to our API gateway. And we do that by creating an S3 bucket, uploading the CA chain into that bucket, and then configuring the API gateway with a path to that bucket, and saying that, hey, we want to do mutual TLS, and here is the CA chain that you need to use to validate incoming client certificates. So then application connects, the client certificate is provided to API Gateway. API Gateway validates if it's signed by the same CA that it knows about, and if it is, traffic is going to be allowed. Now, if we're moving on to authorization, we're going to start with a HTTP API option and how JWT Authorizer works. So in this scenario, we're going to use, again, an OpenID Connect identity provider, but we'll use it for authorization. So API Gateway is not going to do any redirects of the user. It will expect the user to connect and provide the access token straight away, and it will just validate that access token. So to make it work, we still need to create some client on our IDP. This time it's called API Gateway. We need to configure our API Gateway to be aware of that client ID. And we also need to specify which header is the API Gateway expecting to receive the token in. From there, it's on the application side, it's the application responsibility to connect to the identity provider, complete the authentication process, use a different flow to receive all of the necessary tokens, and then use the access token to connect to the API Gateway. So now the access token is put in the authorization header. API Gateway is expecting to see that header and expecting to see the token in that header, and then it will validate it against the IDP, and if it's correct, it will allow the traffic to connect to the backend. Now, if you're using REST APIs, we don't support a native JSON Web Token authorization, but you can build one with Lambda. So you can have a custom Lambda authorizer that will look at anything that's being sent to the API Gateway, and you can validate whatever that is. I'm showing you an example, again, with an access token, but that Lambda authorizer can look at anything. It could be a text string. As long as it's matching, traffic can be allowed. So in this scenario, we would still expect the application to receive all the tokens and then be able to use that authorization token, put it in the authorization header, send it to the API Gateway, and we would need to configure a Lambda function to look for that authorization header, check that token, validate that token, and then decide if that traffic is going to be allowed or not. Okay. So if you want to dig deeper into some of the options for authentication and authorization for HTTP APIs, there's actually a really good session from reInvent 2020. So I recommend you check it out. And with this, I'm going to hand off to Jamie to talk about service-to-service communication with VPC Lattice.
Thanks, Tom. So Tom had covered a bunch of services that are, let's say, a little bit more well-known, right? API Gateway. Ava is a little bit newer, of course, and ALB. With Lattice, we announced it last year as a public preview at reInvent, and then we GA'd it recently. So I'm going to also talk a little bit about how it works and the pieces that put VPC Lattice together. The other thing I'm going to do then is, of course, weave in authorization, authentication, identity into that, because that was a very fundamental piece of how this service was created. So we have Lattice here, and as Tom mentioned, it is a service-to-service type construct. So you see on the left and on the right, it's very, very similar services, right? We've got our Amazon EC2, Lambda, IP. Our ECS is fronted by our elastic load balancing. And on the left, it's the same thing. And the main reason is this is an internal thing, right? This is not meant to be exposed to the internet. This is meant to be facilitating communications, authorizing your communications, and setting up those pathways and actually using a data plane between those two. And we use a bunch of different pieces for that and a bunch of different services. So for instance, HTTP, HTTPS, gRPC, traffic splitting. There's a lot here to talk about. And then, of course, we are also integrating with our well-known services. We have, of course, IAM, which is one of the backbones of how we set our policies and how we authenticate and identify the different resources that are being used and actually facilitating the communications and gatekeeping, if you will. We also have our certificate manager. Most people know about this. This, of course, is allowing Lattice to use certificates. It will pull from the ARN that you have when you add the certificate in the certificate manager. And then to share this with multi-account, we have AWS Resource Access Manager. And keep in mind, too, VPC Lattice is a regional construct, right? So it stays within the same region that you're using it in. It doesn't cross regions. And we do this on purpose because we don't want to have any cross-region dependency. We don't want to have one issue or region in one area go down, and then all of a sudden it starts breaking your applications. Now I realize this is a lot to take in, right? That last slide had a lot of pieces to it. I didn't address all of the different elements in there, but what we'll do is we'll go ahead and we'll start breaking this down. So VPC Lattice, we've got 3 VPCs, right? We enable Lattice on those VPCs. Lattice actually allows for connectivity. So it will actually facilitate from those services to communicate with one another through the Lattice data plane. It doesn't go through Transit Gateway. It doesn't go through your VPC peering. It actually goes through Lattice instead. It's also multi-account, as I mentioned. I have here account A, B, and C. This will allow you to bring in different parts or different elements of your business, different lines of business, depending on how you've separated things out. We know that not everybody has a flat network, right? We know that a lot of networks get very, very big, and they use accounts to get past things such as limits, all those things. Lattice is fully in support of this. Then we also have, traffic management. So let's just say in account A and account B, we have Kubernetes, right? And one of the most common things, if you're using Kubernetes, the managed service, is you need to upgrade. We want to make sure that you're on the latest platform. That's not exactly the easiest thing to do. And it's sometimes burdensome to get the network to help you with those upgrades. Well, now we can set up pathing. So A and B, let's say A is the new version and B is the old version, and we've gotten to the point now where we're splitting traffic, and then we can go ahead and bleed traffic over to A, and then eventually get rid of B and then upgrade it. So it gives you that ability and control. We also have path-based routing. So again, in my example, account C is holding /app A, or /app1, right? So it will know that if you're going to call that particular string, it's going to go ahead and send traffic to the appropriate service that you've set up. And then, of course, the purpose of this talk, security. And we have a couple of different types of postures that we have with security, right? We have macro and we have micro or granular security. You want to do this, of course, because you don't want to get too insane and every little element having every single detail of redundant security, because that is a very big pain to manage. So what we usually recommend folks do is they'll apply the macro security on what we call the service network, which we'll get into, and then granular security is applied to your individual services. We integrate with IAM. IAM is, again, one of the backbones of this. You've all know IAM, right? Whenever you sign into a console, and you'll hear me repeat this a couple of times, you're using IAM. When you're using managed services, we're using IAM in the background. And then, of course, it also honors security groups. So those fundamental or primitive networking or infrastructural security elements are still in play here. So IAM and SigV4, which we use with IAM, were two of the main things that we've chosen to build our security platform on for Lattice. Why did we do that? So, as I've mentioned, IAM is something that has been used on a global scale. We've been using IAM now since AWS pretty much has come out, right? Since we've been using that platform. Every time you log in, it's globally available. We know how it operates. We've heard from you, our customers, on what we need to improve and what we can't improve. It's well known. And it's part of something that we call hands-off secrets management, or HOSM, as it is. This is basically setting a policy and letting that policy run. SigV4 is request-level authentication. So you can think of it as every single time someone makes a request of your application, right, it authenticates that every single time, as opposed to authenticating once and allowing a bunch through. This could also be built directly into your code, so you can take advantage of this. We use it all the time, again, more or less eating our own dog food. And then if you need to, or if you prefer to, you can offload using this with our SigV4 proxy, which is available on GitHub, which I have listed here. Basically, it'll offload the HTTP requests and forward them to the host. This is a link to the actual, I think it's a Git repository. So I mentioned hands-off secrets management, or HOSM. What do you get with that? What's the point? Why are you calling this new thing? Well, this is a culmination of distribution, being able to centrally distribute your security posture through VPC Lattice, rotating it, changing it as you need to. And one thing, too, that most people don't quite realize is revocation. Revocation is actually a big thing. When you go through and you set your security posture today without VPC Lattice on all of the different elements within your application, if there's a change or if something expires, that whole, like somebody leaves or something moves, we have to now go through all of those elements and remove those pieces. But with VPC Lattice, using SigV4 and using IAM, you can actually revoke in one single location. Where does this apply? Well, these are the elements that you saw within the first slide that I showed, where you can do it to Amazon EC2 profiles, roles, Lambda function roles, as well as IAM roles for Kubernetes. So let's talk just a little bit of note on SigV4. Basically, the verification of the identity of the requester. So it basically looks for valid access keys. It authenticates the request as they come in, right? So you have your access key ID and your secret key ID. It also, in transit, looks at all of the elements that the traffic passes through. Pieces like, well, time, the ARN of the service that you're using, the actual region ID, all of those elements that you use to make up your service, it will actually use as part of its in-transit data protection posture. And then, of course, it also protects against reusing any of the signed portions. Every 15 minutes, it rotates. So if somebody gains access to your keys, your token, and your ID, in 15 minutes, it'll no longer be valid. Also, they have to have the assumed roles because we're tying this in with IAM. So it all kind of works together, and these are always validated on a continual basis. So how does Lattice use SigV4? First, you sign your code. Then you validate your code during your runtime. And then from there, the code initiates the SigV4 via the hands-free credentials. And then after that, VPC Lattice will then validate that as it goes through its control plane and data plane. So SigV4, I mentioned this a couple of times. What are the elements that are used in SigV4 that make it secure? So on the right, we have the string we want to sign. We have our request elements. We have the different pieces of the signing key. And at the end of it, we'll have our signature. So on the left are the elements that you use and that you have used to put together your services and your resources, right, to use VPC Lattice. So we have our signed element or key and the time frame. So that goes into our date key. And then, of course, we have the region that we're in. We're going to use those elements. And then we're also going to pack our date key into that. And then we have our service, our ARN, what we were actually getting down to, the more level control. We're going to add that and then pack our date region key into it, which will generally create our signing key. All of these elements will always be validated through the entire process of using VPC Lattice. So VPC Lattice will attempt to authenticate any SigV4 coming in, right? And we do have an SDK that will provide access for this, so you can actually add this into your code. I'll give you an example. I'm using Python. It's one of my favorites. It's also up on the public documentation too, but I'm just going to highlight here where we're calling out SigV4 in this string. Now, one thing I want to note, it's at the bottom here for the nota bene, is like Lattice does not support payload signing. So you have to use the AMZ content SHA-256 with an unsigned payload if you want to take advantage of this. Now, I did mention that I said Python's my favorite, but we do have a couple of other ones, the Java with the interceptor and one without the interceptor. So this will link you again to the public documentation that gives you examples for those. So now we've talked about a little bit about IAM, we've talked a little bit about SigV4. Now let's get back into more of the meat of Lattice, right? How does VPC Lattice even work? What does it do? Who does what? How is security applied? What is the whole point of roles and identity? Who does what? So the first thing is who should be responsible for creating the service network? The service network is the thing that has that data plane and control plane that all of those services talk on. And of course, that's the admin. The admin, as I mentioned, creates the service network. And then after that, they will actually define the access and monitoring. So it's an important piece. Monitoring of the service network is different, or not, is separate than monitoring of the services. And then they'll go ahead and associate this with VPC services. And then remember, I showed you in the first slide, you can go ahead and share this with other accounts with RAM, Resource Access Manager. So let's dive in a little bit of what the policy would look like, something simple that the administrator would set up. So here we have an IAM policy, right? And we're basically going to say we're going to allow any authenticated request to any principal to which this policy applies. We're also going to allow access to any resource in this service network, but they have to be a part of our organization, right? So we're setting that macro security on the service network, saying you have to be in my org. If you're not in my org, you can't participate. So therefore, we'll go ahead and apply our policy, we'll put it in place, and it'll now start protecting what we have in our service network, saying, okay, you have to be in this particular org, and you can go ahead and participate. So that's set up. So now we have our VPC Lattice network setup. I've got it drawn kind of like as a donut. I've heard people refer to it as, as a Ferris wheel, but I'm a little hungry, so it's a donut. And we have our services. We're ready for our services to come in. So this piece represents the Lattice service network. And then we have the proxy data plane, because VPC Lattice is essentially a large proxy, right? And it extends through multiple VPCs. You don't have to configure individual proxies in every one of those VPCs. You can go ahead and configure your listeners and set it to your targets, and then away you go. It basically simplifies the connectivity between those services because you are not using this, right, with Transit Gateway and with VPC peering for your communication or your packets sending back and forth to your services. This is actually sending those packets back and forth for you. This doesn't mean you can't use it with Transit Gateway and with VPC peering for other use cases. Remember, Lattice is layer 7. If you have layer 4 traffic, you still need to have that set up. Also, keep in mind, too, that when you're setting this communication path up, if you give the services connectivity over the layer 4 or over Transit Gateway outside of VPC Lattice, and you don't just use VPC Lattice, they can still communicate. Lattice isn't going to go over to Transit Gateway or to your peering and say, okay, I have policies, you can't talk. It doesn't work that way. It only applies to itself. And the second piece is, of course, the control plane. This is where we go ahead and set our IAM policies. We use our SIG v4. We do our constant validation to make sure that, say, again, as our example policy, that you are part of this particular organization. So now, who's responsible for creating our services? Well, that would be the service owner. These are your devs, right? The developers who want to actually create part of the application and participate. And we can then give them some control over their services, and we can then allow them to create it. They can define their routing, they can define their authorization, and then when the VPC is enabled for Lattice, they can associate this to the service network. So let's take a little peek at what a service is. We have our VPC, right? We have our service that we want to create, which can contain things like EKS, as I mentioned. It can have EC2, we can have Lambda, right? All of those things working together create our service. So the next thing we do is we enable that VPC to participate in the network of our VPC Lattice service network. So now let's take a look at a policy that we can set to this service. Again, we have our IAM policy. We've set it up so that it allows any authenticated request from the service 1 role, right? That's a role that we defined that we're now going to say, okay, if you want to access us, you have to have this particular role. And then we can say we allow the access to any resource element in our service network. So we're basically saying we want, just like we had our service network say you have to be in an organization, we can say you have to be part of this specific service network to actually communicate with my service. And then we allow it to perform a get function. And then we go ahead and we apply this policy. So the policy is basically saying you have to be part of the service 1 role, we're protecting our particular services, and you have to be part of the service network to communicate with my service. And this is controlled by this service owner. So we have our services. We're going to go ahead and we apply our policy, right? So now where the service is defined, we take care of attaching this from the VPCs. Now that we've said the VPC has been enabled for VPC Lattice, we've now applied our policies to the service network. That was done on the service network owner, and now the service owner has applied the policy on theirs. Our VPC has VPC Lattice enabled. This is now basically saying anytime you want to talk from that VPC to another service that's part of the Lattice network, Lattice is going to take that request. It's going to send it through its control plane and data plane, and then send the traffic over, validating it continuously as this goes on. So next, we have our Lattice-enabled VPC. As I mentioned before, it's part of our organization. We can go ahead and have that attach, and it is now authorized to use. So this is just one service. Let's take a look at multiple services. Now, in this diagram, we have our identities of our services, who they are, who they identify as, what roles that they are assuming. And then we also have our elements inside that have a threshold or a gateway to say who they will accept from. This helps us define routing and pathing. who can speak to who, right? So as you can see here, I've got my service 1. Its service actually has an identity or assumed role for 2 different things. It could talk to service 3, it could also talk to service 2, and so on. As you look around the circle, you can take a look at the different color coding that allows you to set your security, your posture, your elements, as well as your ability to communicate. So I mentioned before about what happens if we want to revoke our policy, our central revocation that we want to do. So we're going to remove this, right? So what does that mean for our services? So we've removed it. Now we're basically saying, okay, we have it set up now where service 3 no longer is going to be, our service 1 and 2 are no longer going to be allowed to access service 3 because service 3 is no longer accepting from the green. So how can we basically validate this? How can we test this, right? And how can I show you these different elements? So we're going to use curl. So from our curl statement that I have here, which is fairly long, I have a couple of things that are highlighted because these are variables. We have our access key ID, we have our secret access key, and we have our token. And we basically, within each of those, will pull this out. Now keep in mind that I've got my little prompt there, or what would be my console, inside service 1. So I'm using and operating from service 1's role. If it was outside, I wouldn't be able to do this. I also have my other 2 elements. I pull those out, and then from there, I can send my request and get my response, right? Now keep in mind, again, if I'm using these elements, and I have them now stored in those variables, after 15 minutes, remember, it will reset. So you can't do this again. You'd actually have to pull them over and over and over again. Remember, constant validation. Now, I also mentioned security groups, right? They still apply. You can use security groups inside of VPC that's enabled for Lattice to allow different elements within your VPC to specifically be blocked from participating from the Lattice network. There's a note about this, though, that I want to make sure that we all understand is that it's a first level defense, right? This is the on-off switch, yes, no, the hammer, if you will. They also can be referenced for secondary levels of control, but they need to be figured in when you're setting up your routing, right? So if you have different elements of your service and you have security groups in that service that don't allow it to speak to the Lattice network, it's not going to work. And you also have to keep this in mind for troubleshooting. And the reason why I bring that up is that old scenario where it's like you go through a rigorous troubleshooting in the old world and you find out that the cable wasn't plugged in, right? That's the security groups. You have to make sure that they are set up correctly. So, observability, logs, and metrics. You can enable logs and metrics with a single API call. You can look for your access and set up your visibility with one call. Basically helps with audits and compliance. And you can have it so that the devs can send logs and metrics to their tool of choice from their services, right? Without being interfered where the admins are setting up their logs and metrics to their tools and choices. So it's not the same thing where one person or another has to basically tell them, hey, you have to use my method because this is what I know, or I want to use the new hotness as a lot of devs like to do because there's a lot of reasons. And you've got your admin saying, you can't do that because I don't know that tool. Now you can kind of separate that out. Another thing too, which is kind of interesting with VPC Lattice, is the service directory. Within the service directory, you have a list of services that have been shared to you or that you've shared out, right, in one single pane of glass. Our service owners love this, right, because it gives them a central place to do an audit and check out what's going on and make sure the things that are needed, as well as you can copy out the URLs and use them within your code. And then our admins can use this to audit everything again and basically make sure that everything is created the way it should be. Everyone has the correct access that they should have. So devs can use it as almost like a menu of sorts of pulling out the services that they want and gaining access that way, as long as all the policies and IAM is set up. And then our admins can use it in the fashion of central location to do our audits. So there's some comparisons of like, why are we using IAM instead of MTLS? So to give an example, because Tom has covered MTLS fairly well, when you're using MTLS, right, it's kind of like going to that club and you go up to the bouncer and you say, hey, I want to gain access. And they roll out a red carpet and everybody behind you in your party goes on that red carpet. They're protected. No one can mess with them. And they all go in. IAM is a little bit different where every single member of your party has to have the right role. They have to be part of the right environment. MTLS is that protection from the outside world. You know, it's basically building that VPN, or not VPN tunnel, but that encrypted tunnel. IAM is everyone inside. Are you all doing the right thing? Are you all part of the right element? Are you all participating the way you should be? So again, we focus for authorization and authentication, MTLS being the purple and IAM being the green. I won't really read them out to you, but again, going back on my one is everything is being evaluated through an encrypted tunnel. That tunnel is the thing that you're basically making sure is set up. And then the other side is all of the elements coming in, all that fine-grained pieces of all those elements or all of those ARNs and different pieces of your service that are all allowed to do what they're supposed to do. So why IAM? Again, it's trusted. We've used it over and over again. We're going to continually use it, and we're going to continually put our efforts to it. We're eating our own dog food, right? This is built into all of AWS primitives. When we come out with something new, it's going to have IAM capabilities built in. So VPC Lattice isn't going to be a one-stop and then that's it. When we continue to move on, it's going to basically be automatically included to it. And then IAM authentication, again, is done and invalidated on a continual basis. So there's one other thing, too, that we've seen a comparison to is like, you know, VPC Lattice and API Gateway. Why use one versus the other? Which one's better? Which one would win in a fight, right? And the story really isn't which one is better. It's more of they do different things. API Gateway basically does API management, right? It focuses on that kind of integration, whereas VPC Lattice is a networking service with your services as well as your service network, and it focuses more on the service-to-service communication. Most importantly, you want to look at it as how can they be used together? And I love doing all these, tie this all in together, so we'll use some elements from Tom's portion of the presentation as well. Let's just have an example. Within a region, we've got 3 VPCs. We've got an IGW to allow access into our application. We've set up our services. We're using a mixture of Kubernetes and a mixture of Lambda. We set up our VPC Lattice network. You'll notice that the color coding is the same as my examples before. So we have our roles that we have assumed by our services, as well as we have our different elements inside, right? So then from there, we have internal employees, and we've decided we're going to use Ava. Ava is going to attach to an ALB. So then we have those elements that are in place. We also have our client. This is where we want to allow people in, right? So allowing the internet access through, it goes to that ALB. That ALB is allowed to speak to service 1. And then from there, we have our API gateway for our API calls. It's allowed to speak to service 3 and to service 1. So each of those packets that are going through are authenticated. They're validated through the VPC Lattice network. Every part of this diagram here that's moving is the way it's supposed to be. If you move one thing out of place, if there's a policy that's revoked, things will stop from one central place. If people are not allowed to come in through our Ava anymore, you can block it right there. So this is kind of the whole tie it all in thing. I'm sorry that I was cut off from you guys, but thank you very much for attending, and have a good day.